Hello friends, this is Bright here. Now we are going to see the concept multithreading in Python. So let us see what is thread. The basic definition goes like this. It is a unit of execution on concurrent programming. Let me illustrate with a very simple example. I am going to open Microsoft Word. So I am going to type something. Life is good. So this is done by a thread. The moment you open an application, we can say that the main thread is opened. And then I started typing. So it is reading the data from my keyboard and displaying it there. That is done by a thread called child thread. Now, there is a term called multithreading. Multithreading means it allows a CPU to execute many tasks of one process at the same time. Now the typing is one thread. I am going to do some spelling mistake like this. Good. And press the space bar. You can see that immediately it is showing some spelling mistake. That is done with the help of another thread which is running in parallel with my typing thread. So now there are three threads running. One is my process, that is we can say that the main thread is started. Now when I started typing, the first child thread called typing thread, and when I did some mistake, immediately it is detected by another thread called auto spell checking thread. So now there are three threads. So these three threads are running in parallel. That is called multithreading. So these multiple threads execute individually while sharing their process resources. And there are two terminologies, multithreading and multiprocessing. I will explain it with a very simple example. Multithreading means in one process, for example in Word, multiple jobs or multiple tasks are running in parallel, and each task in a process can be called as thread. So within a same process, multiple jobs are happening. Multi-process means, so this is my presentation software, Keynote. Along with that, Microsoft Word is open. So now two processes are running in parallel. That is an example for multi-process. So multi-process means multiple applications or multiple processes are running in parallel. Multi-threading means in one process, multiple threads are running in parallel. So to implement multi-threading in Python, we have two modules available. One is thread, the second one is threading. So thread is an old one. You can see that it is deprecated. So we'll be using threading module in our demonstration. So before going for the demonstration, we should understand the life cycle of a thread. So whenever we create a thread, we can say that a new thread is born. So it is a small task. A task is created or a thread is born, thread is created. But just by creating that thread, we cannot say that it will go immediately into the processor. It remains there. What we have to do is, there is a predefined method called start. We have to apply the start method upon this newly created thread. Then its state will be changed from born state to ready state. Now this thread is ready to be executed in the processor once it get into the processor. So immediately again it will not go into the processor. Imagine that we are creating two threads. So two newborn threads will be available. When we apply thread 1.start, it will come to the ready state. Thread 2 dot start, it will come to the ready state. So all these will be queued in a structure called ready queue. Then a scheduler will be there that will assign a particular thread into the processor. And when that happens, we can say that it enters into a state called running status. So every thread has some assigned job to be done. For example, let us say that we have a thread T1. It has to perform sum of n numbers. So that logic we have to keep in a predefined function called run method. So we have to override this run method, and the run method contains the body of the thread to be executed. So now when the thread is in the processor, we can say that it is in running state. Then if there is some timeout, imagine that a thread T1 is running there and timeout is happening, then it will exit from the processor, it will go back to the ready state. It is due to the time slicing job. Otherwise, a thread can voluntarily come out by applying the yield method. There is another state called blocked state. It means it is waiting for some input-output operation. So once that operation is done, again it will come back to the ready state. There is another state called waiting state. Imagine that a thread T1 is running in the processor. So at that time, the state is running state. Now, some condition should be met so that this thread can go smoothly. For that, we can write some condition. If this condition is not yet met, call the wait method upon that thread. The moment we call the wait method, the thread will leave the processor and it enters into a state called waiting state. And once the things are ready, everything is available, we have to bring back the waiting state thread to the ready state by calling the method notify. If you don't call the notify method, the thread remains in the waiting state. It never comes back to the processor. The moment we notify, it comes back to the ready state. Then depends on the scheduler, it will go again to the depends on the scheduler, again it will enter into the processor. There is another interesting state called sleeping state. For that we have to call the method sleep. We can sleep the thread for particular amount of time. It is mentioned in seconds. And once that sleeping period is over, it will wake up and go back to the ready state. Then from ready again to the running state with the help of scheduler. Once the entire task is done, you can see from running to dead state. It means the entire job is done by the thread. It will come to the dead state. It means that thread is removed from the memory. So this is the entire life cycle of a thread from birth to death. So once the entire job is done, from the running state, it will come to the dead state. Now let us see a very simple demonstration. So here I'm using PyCharm as my editor. I'm going to say that print welcome. It is a simple script. When you run it, welcome. So the moment you launch a program or run a program, we can say that the main thread is running. So how do we get the name of the main thread? For that, we have to import a module called threading. Print. Using the module name, there is a method called current thread. When you call the current thread, it returns the reference of the current running thread. So we'll get the current running thread object dot get name. Now you can see welcome followed by main thread. So whatever programs we have seen before, that everything was running in the main thread. And in this program we are going to see how we can create multiple thread. That is, from the main thread we are going to create new threads. First of all, from the threading module, I am going to import a predefined class called thread. Then create a subclass of thread. So to create a class, use the keyword class, then give a name for the class. Let us say that my thread. And to make it a subclass of thread, we have to say that class my thread of thread. Define the constructor and call superclass constructor thread dot init. This is mandatory. Now, as I mentioned in the presentation that there is a function called run method, where the run method contains the body of the thread. So now in this subclass of thread, what we have to do is override run method. So define run. So the run method contains body of the thread. So we are going to display from 1 to 5. For that I am going to use a for loop for I in range 1, 6. Print I. Now I am going to run again. You can see that no new thread is created. We just created a subclass of thread and only the main thread is running. Now we are going to create the first child thread. Create first child thread. What we are doing is just create the object for my thread class. Let me name it as T1 equal to my thread. That's all. So what is the status of this thread object T1? Its status is born state. So we can say that now it is in the state born state. A thread is born. Now what we are doing is change its status from born state to ready state. Change T1's born state to ready state. For that, T1 dot start. Now let us see what is the outcome. You can see welcome main thread, then 1, 2, 3, 4, 5. So start is the method that will change the newborn state to ready state. Let us create one more thread. create second thread, T2 equal to my thread, and change T2's bound state into ready state. For that, T2 dot start. You can see welcome main thread, then 1 2 3 4 5 1 2 3 4 5. I am going to run again the same output. Yeah, now see that. This time we are getting some jumbled output error 1 2 3 4 5, and 1 is printed along with 5. It means the two child threads T1 and T2 are performing their print I operation at the same time. This is called racing condition. You know, the car racing, bike racing, right? So both threads are racing each other. That is why 5 and 1 are printed in the same line. Let me run once again. Yeah, we can see that 5 of one thread and 3 of another thread, both are coming in the same line. This is due to race condition. So whenever we run it again, we may see some different outcome. Now, how do we know that this one belongs to second thread or first thread? We will print the name also. Now, so the run method contains the body of the thread. We are going to say that threading dot current thread dot get name. So threading dot current thread, it returns the reference of the current running thread, that dot get name. Let us see that. You can see one thread 1, then second child thread 2. These are the default name. So first child thread takes a default name thread 1, second child thread takes a default thread name thread 2. Suppose we want to customize the name, that can be done. For that, before calling the start method, we are going to change the name. Change the name of T1 thread. For that, T1 dot, there is a predefined method called set name. We can say that, let us say first. Like that, we are going to change T2's name. Change T2's name, T2 dot set name second. Now let us see the outcome. You can see 1 first, 2 first, 3 first. Always we cannot get the same order. You can see there is a racing situation. Here also there is a racing condition. Yeah. So this is just an introduction about thread concept, multiple threading, and how to create multi-threads or multiple threads in Python. In the next video, we will see more details about multi-threading in Python. Thank you for watching this video.